Good morning, class 10. Welcome to physics class. So, once again, I am with a new topic in physics. Today, we'll be studying about the electromotive force and the terms related to electromotive force, such as voltage drop, such as terminal voltage. And then, after that, we'll discuss about the term like internal resistance of the cell and the relationship, the mathematical relationship between EMF, voltage drop. Okay, then again, what you call this one, terminal voltage and internal resistance of the cell. So this all we are going to discuss today. So let's start today's class. So first comes, so let me draw first the cell. So here we need to start from the topic today, EMF. EMF, that is electromotive force of the cell. In short, we call it EMF. In order to understand EMF, let us draw the cell. Okay, the cell is filled with electrolyte. Okay, it is filled with electrolyte, and in this electrolyte, two rods are immersed, which we are called as electrodes. Okay, and these are the two terminals of the electrodes. Now see, this EMF has got two different definitions. It can be defined in two different ways, qualitative and quantitative. Okay, qualitatively we can define EMF by saying that EMF is the potential difference between the two terminals of the cell when it is not in use. When we are not using a cell, then the potential difference which exists between the two terminals of the cell is what we call EMF of the cell. Okay, EMF of the cell. Now, quantitative definition, because quantitative definition gives the mathematical expression. Okay, so that is why it is better to go through the definition, quantitative definition rather than qualitative definition. So, quantitatively we can define EMF by saying that it is the amount of work done. It is the amount of work done in taking a unit positive charge, okay, unit positive charge through the external circuit and inside the cell, okay, or to make one complete round throughout the external circuit and internal or inside of the cell is what we call the EMF of the cell. That means, suppose this terminal is connected with the electrical appliances. Let it be a resistor. Okay, suppose this is the positive terminal, this is the negative terminal. Okay, then to carry these, the energy spent or the amount of work done to take this positive charge one complete round throughout the external circuit, and then after that through this electrolyte, and again come back to the same position. Okay, how much amount of work is done? If you calculate that, you get the value of EMF. So this is what we understand by EMF of a cell. So from here, first we need to understand that it is denoted by the symbol. It is denoted by the symbol epsilon. Okay, it is denoted by the symbol epsilon. Okay, epsilon, and then next it is measured in, its SI unit is like that of potential difference, which is volt. It is measured in volt. Okay, volt, that is V. The SI unit of EMF, if you are asked, you need to write volt. Okay. Now mathematically, this EMF, as I just now explained to you, that it is the amount of work done to take a unit positive charge. Okay, to make one round throughout the cell. Okay, from the external circuit inside the cell to make one complete round, how much work is done? Okay, gives us the value of EMF. So if W amount of work is done to take the charge to make it one complete round inside the cell and through the external circuit, okay, if it is W, then again and then the charge associated with this positively charged particle is Q, then EMF is given by capital V by small q. Okay, sorry, W, that is the amount of work done per unit charge, gives us the value of EMF. So if W is the amount of work done to take the charge one complete round throughout the cell, okay, that is from the external circuit and again inside the cell, if W is the amount of work done and Q is the charge associated with the charged particle, then EMF of the cell is given by the formula epsilon is equal to W upon Q. So this is the mathematical expression. Then again next comes the term like okay. Then after that comes the factors affecting EMF. Factors affecting EMF. Factors affecting EMF. So it has been found that this EMF depends upon the two main factors. That is the material of the electrodes by which the electrode is made up of, and the second one is the electrolyte which is being used in the cell. So two main factors are there on which EMF depends. Number one, nature of the electrode. Okay, two factors, nature of the electrode. By which material the electrode is made up of, nature of electrode. And then again the next one is the electrolyte. It depends upon the electrolyte. Okay, the electrolyte which is being used in the cell. Okay, two factors are there which affects the EMF. Then again the next comes the important point to be noted down, that EMF does not depend upon the shape of the electrode. It does not depend upon the distance between the electrodes, and the third point is that it does not depend upon the amount of electrolyte which is present in the cell. It is independent of the shape of the electrode, it is independent of the distance between the two electrodes, and it is independent of the amount, that is concentration of the electrolyte which is being used in the cell. Okay, so these points are very very important, okay, that you need to remember. Then after that comes the next term, that is terminal voltage. Okay, terminal voltage means, now to define qualitatively, you can say that when the cell is in use, the potential difference which exists between the two terminals of the cell is what we call terminal voltage. Now to define the same thing quantitatively, we can say that terminal voltage is the amount of work done to take the unit positive charge through the external circuit. Means from here to here, to take the charge from positive terminal to the negative terminal, how much work is done. Okay, how much work is done gives us the value of terminal voltage. Okay, it is denoted by capital letter V. Okay, it is denoted by capital letter V. So just now we came to understand that quantitatively the terminal voltage is the amount of work done to take the unit positive charge through the external circuit. Okay, through the external circuit. So as I told you that it is denoted by capital V. Okay, it is denoted by capital V, and then again its SI unit is volt as it is terminal voltage. Then again, if suppose W amount of work is done, that is small W dash amount, let us denote it by W dash. If W dash amount of work is done to take a unit positive charge of Q, okay, through the external circuit, then mathematically this terminal voltage is given by the formula V is equal to W dash upon Q. Okay, so this is the mathematical expression of terminal voltage. Then after that comes voltage drop. Now voltage drop means it is the amount of work done. Quantitatively we can define, that is, it is the amount of work done to take the unit positive charge from one electrode to the another electrode through the electrolyte. Okay, that means from here to here, okay, how much work is done. Okay, gives us the value of terminal voltage drop. Okay, and here capital V. Terminal voltage means it is the amount of work done to take the unit positive charge through the external circuit. Okay, from one terminal of the cell to the another terminal of cell. Then again here, voltage drop means it is the amount of work done to take the unit positive charge from where? From one terminal to the another terminal through the electrolyte is what we call the voltage drop. Okay, voltage drop. Just now I told you about the voltage drop. Voltage drop is denoted by the small letter v. The small letter v. If small w amount of work is done, if a small amount of w is done to take the unit positive charge q, okay, through the electrolyte inside through the electrolyte, okay, then the voltage drop is given by the formula small w divided by q. Okay. So from here what we understand is that if you add terminal voltage and voltage drop, will get the EMF of the cell. So in order to calculate, see, you can see, as we know that EMF means what? To take the unit positive charge to make the amount of work done to make one complete run. Okay, this unit positive charge. From here to here it is terminal voltage, from here to here it is voltage drop. So if you add both, what you get? You get the EMF. So here we can write that EMF is equal to terminal voltage plus voltage drop. So this mathematical expression gives us the relationship between EMF, terminal voltage and voltage drop. Okay. Then after that comes internal resistance. Internal resistance we have already discussed, that is, it is the obstruction offered to the flow of charge is what we call the resistance. Now here what happens is that when the charge flows through the electrolyte, okay, when the charge is carried through the electrolyte, then what happens is that the electrolyte offers resistance, okay, to the flow of charge. This resistance offered by the electrolyte is what we call internal resistance. Okay, internal resistance. Now once again we know that suppose in the external circuit I amount of current is flowing, and the resistance of the external circuit is capital R, then the terminal voltage is given by the formula V is equal to IR as per Ohm's law. Okay, then same way voltage drop, if suppose the internal resistance of the cell is small r and I amount of current is flowing through this electrolyte, okay, then the voltage drop is given by the formula capital I small r. Okay, capital I small r. Then now the same thing we can put here in the previous equation. So we get the expression that is E is equal to epsilon is equal to, in place of here I can write what? Capital I r plus capital I small r. Okay, or epsilon is equal to I bracket capital R plus small r. So this relationship, the final equation gives us the relationship between EMF of the cell, electric current flowing through the cell, okay, and then the resistance of the external circuit, and again the internal resistance of the cell. Okay, so this expression is again very important. So students, so let us keep up to here today. The remaining topic we will discuss in the next video. Thank you very much.